All right, keeping up with our little theme here of exponentials, we're going to look at, modeling growth and decay because an exponential function can model growth and decay. It just depends on, you know, this is actually kind of cool. This is used a lot in science and forensics and things like that. There's growth because we usually talk about bacteria and stuff like that. We actually talk about that in finance and stuff like that. And in decay, you talk about that in forensics and carbon dating stuff. This actually has a lot of uses outside in the real world. All right, A is called the initial amount, and it's got to be greater than 0. Okay, it can't be like, nothing. Okay, you can't start off with a negative something. All right, B is called our growth value, and it's got to be greater than 1 for growth. That kind of makes sense. And it's got to be between 0 and 1 for decay. Now, normally I would say if it looks like a fraction or a decimal, but you have to kind of think about that. Because if it's between this, when you multiply by like a decimal or a fraction, that's kind of dividing it. Okay, and this is multiplying it. So that's kind of what we need to look at when we go through this. All right, so basically, we're just going to say, identify the initial amount and growth factor. So initial amount, growth factor, initial amount, growth factor, initial amount, growth factor. That's it. That's how easy this is, okay? Now, it says identify the initial amount and decay factor. Now, all these are going to be growth right here because notice this is 2, that's bigger than 1. This is 1.5, that's also bigger than 1. And up high here, barely sneaking in there, this is going to be growth because it's 1.03. Okay, just enough. Okay, it's kind of like when some of y'all have like a 64.45 and you need it to round up to 65 so you don't get an F. All right, and kind of the same thing here. This is A and B. This is A, this is B, this is A, and this is B. Now, these are all decay. This is, between, because it has to be between 0 and 1. Well, that's 0.5, that's halfway. That's close to 0. And this is 2/3, which is not really 1, okay, but it's still a decay factor. All right. Now it says, now this is where it's used. We didn't get to have this past year. Thanks, COVID. But single elimination tournament starting with 128 teams. Half of the remaining teams are eliminated each round. What's the initial amount? Well, we start with this many. All right, this says, it tells you a decay factor. Half, so we could actually say 0.5. Okay, using parts A and B, write a function. Well, y equals our initial value, and this is our growth or decay factor, our B right here. Now it says tell how many people be left after 5 rounds. So what you would do is you would say 128, 5. Now I'm going to use the caret key because that's how I'm going to type it in the calculator and do 5. So 128 parenthesis 0.5 caret key and then 5. Okay, that's how I did it. There we go. And then I hit enter. 4. So 4 teams. Okay. Whoa, that can't be all of it, is it? Oh yeah, there's a your turn. There's lots of your turns on this. I didn't bring them in. I ain't gonna do it. This is kind of easy. You can do this stuff. I know you can do this stuff. Okay, short, simple, to the point. Love it. Love it. Roll Tide.